recently found a Danish VFX company named Outlanders Design. They designed this Jesus figure using a dithered grid shader that I thought would be cool to replicate and put into a game. There are a few main considerations when it comes to these sorts of shaders. Should it be done in post processing? Is it 2D or 3D? What are the artistic constraints? The grid cells fall off in size along the contour of the shape. This tells me a few things. First, there needs to be a gradient that is commonly referred to as a sign distance field or an SDF. There are a variety of ways to approach in creating an SDF. Like the Jesus figure, I'll be using a light mask on 3D models as the SDF, and I'll be using post-processing to render each grid cell's size and color. The first thing I need is the SDF via a light mask. Unity's default physically based rendering lights have too many unnecessary parameters and will be too complicated for a simplified render output. Instead, I'll use a more controlled and cheaper approach and only get the light diffuse mask and the color from the additional lights. Now for the fun part. I prefer using code-based shading over graph-based, but this can be done for either. Some features like for loops are not available in Shader Graph, which is a technique I'll be using to displace each grid cell. I won't go through the setup of the code-based post-processing because that will take up the majority of the video, but I'll go through the shader itself. The grid shader is essentially a pixelated shader with a grid of the same scale as the mask. The first step is to simply quantize the screen coordinates by a scale factor that I'll expose as a property of my shader. Multiplying the grid scale directly onto the screen coordinates will result in unwanted rectangle cells. To get square cells, we get the screen height and width and divide them by the scale. This new vector can now be used as a scale factor. This works because we use the screen's aspect ratio to affect the screen's x and y coordinates individually. This also means the squares will remain square no matter what the screen size. If we use these new screen coordinates as the UV for the camera texture, also called the blit texture in code, we get a basic pixelated shader. To create a grid mask, we need to procedurally generate a grid SDF. To do this, we need to create a tiled UV that uses the same scale so each cell runs between 0 to 1 on each axis. Fraction, or frac in HLSL, does this for us. Now, to understand what the grid SDF should look like and why, there are some different approaches that work better than others. One approach is to find the shortest length between a number of points, which is commonly referred to as the Euclidean distance. We can do this, however, each grid cell is a radial shape since the length can be any angle. A better approach, known as the Manhattan distance, which does the same thing but along a grid resulting in angles that are either vertical or horizontal. Imagine taking the shortest route diagonally from you in the city of Manhattan. You would have to zigzag between blocks to get to the destination. To take this approach, we need to center the coordinates of each grid cell so the coordinate of 0, 0 is in the middle. Then we want to use the absolute function so each quadrant of the cell is mirrored vertically and horizontally. Then we want to take the maximum of the x and y channels and 1 minus the result to acquire the Manhattan distance. To give the grid a hard edge, we can use a smooth step where edge 1 and 2 are 1 pixel away from each other and the grid SDF as the input. Now we have a grid. It's finally time to combine our effects, the hardest part. But before we do that, I've forgotten about the light SDF affecting the grid thickness, so let's do that first. If you remember, the blit texture is a light map SDF, but it has color. To target its brightness, we convert the RGB values to HSV, hue, saturation, and value, with this magical function that no VFX artist really needs to understand. But if you want to be an absolute VFX nerd and feed your ego, by all means. Now we have access to the value channel, which we can use as a factor for the grid thickness by using a lerp. Okay, now it's time for the hardest part. We have to multiply the effects. That's it. Now we can do cool stuff like adding noise and adding other masks and displacing cells and